Okay, this is the P2 paper from June 2023. This is question number 5. As we can see by looking at this, it's an exponentials and logarithms question, in particular laws of logarithms, and we're going to be solving equations. So let's have a look and see what they've given us. Log to the base 2 16x plus log to the base 2x plus 1 is equal to 3 plus log to the base 2 x plus 6. There are different ways of doing this one. I'm just going to stick with the idea of getting all the logs onto one side, combining them using the log rules, and then trying to get rid of the log using a power statement. Let's do it rather than talk about it. So we've got log to the base 2 of 16x plus log to the base 2 of x plus 1 is 3 plus log to the base 2 of x plus 6. So I'm just going to take this over to the other side and have all the logs on one side. So I'm going to get log to 16x, log to x plus 1 minus log to x plus 6 is equal to just 3 on the other side. And then we're using the fact that log a plus log b, that can be written down as log AB, and log A minus log B can be written down as log A divided by B. So let's get rid of that, but if I use those, then log of A plus B is going to give me log to the base 2. I can say 16x multiplied by x plus 1. That's combining those two. And then if we're minusing the x plus 6, I can have it all divided by x plus 6. So that is equal to 3. Once I've done that, I'm then going to use the other rule that we quite often use in logs, which is if I have a to the power of b equals c, what I need to be able to do is to write that as a log statement. And the log statement would be that the base is the same, the base and the base, so the base of this power here is the same as the base of the logarithm. And then I remember the fact that a logarithm is a power. So if the logarithm is a power, then the answer to that bit must be my b there. Well, I can go that way round, or I can start with log x, y equals z, and then do exactly the same idea. So we would say the base of my logarithm is the same as the base of my power statement. A logarithm is a power, so I'd get x to the z there equals y. So using this idea, what I can do is I can change this log statement into a power statement. So let's do that with what we've got there. Cut that out. So we've said in my log statement, the base, that log 2, is going to be the base of my answer, and the logarithm is a power, so the actual answer 2 cubed, that's my power, so that must equal 16x x plus 1 over x plus 6, and now this has just turned into a quadratic. Let's do all the work to do it. We get 8 is equal to 16x x plus 1 over x plus 6, multiply both sides by x plus 6. I'm doing this pretty slowly, really. Let's quicken up on the other side there. 16x squared plus 16x. This is 8x plus 48 is equal to 16x squared plus 16x. And what I'm trying to do is to get to a quadratic, which I'm nearly there. 16x squared plus 8x. Get it all over to one side. Minus 48 equals 0. And then they do this quite often with the AS and the A-level work, where I can divide everything by 8 there, can't I? If I divide everything by 8, I'm going to end up with 2x squared plus x minus 6 is equal to 0. And then I'm fully expecting that to be able to factorise. I get 2x minus 3, x plus 2 equals 0, which gives me x equals to 3 over 2, or x equals to minus 2. Now, always with these ones, just go back and check. Yeah, so for example here, if I had log of x minus 2, I'd have log of a negative, and log 4 there. We can't have that, so we're just going to stick with the term x equals 3 over 2 and discount the other one. Okay, hopefully that makes sense to you all. Really straightforward log question.